Hello everyone! Today we will show you our finest collection of America's funniest home videos. Oops, sorry, wrong script. I meant to say, today we will show you a very interesting calculus topic. Don't worry, you'll end up liking this one. Get your pen and paper out, or your fancy little electronic devices, because we will discuss one of the most famous and useful methods for calculating limits, L'Hôpital's rule. But first, let's talk a little bit about its history and a 17th century gossip. The name of the rule we will be discussing today comes from the French mathematician Guillaume L'Hôpital. He actually wrote the first calculus textbook, and it was based on differential calculus. So, thanks for giving everybody ideas. Alright, so let's get to that super old gossip I promised you all. So, L'Hôpital had a tutor. Yes, he went to the office hours announced on Twitter. Allegedly, he purchased this formula from his tutor, who was none other than the famous mathematician Johann Bernoulli. Johann Bernoulli was a Swiss physician and mathematician. In fact, his whole family were mathematicians. I promise you. Look it up. He also tutored L'Hôpital on calculus, and he allegedly sold his mathematical discoveries to him. Alright, enough with the history lessons and avoiding the math. Let's get to the real problem here. How do you teach math to a chicken? I know how to. Show them a lot of egg samples.
So what is L'Hôpital's rule and when can we use it? It is a very handy tool for calculating limits involving indeterminate forms. What do we mean by indeterminate? We mean forms such as 0 over 0, infinity over infinity, or 1 over 0. In order to know if our function is an indeterminate or undefined form, we can use direct substitution. If we plug x is equal to a into our function, our result should be 0 over 0, infinity over infinity, or 1 over 0. If we end up with 0 over 0, infinity over infinity, or 1 over 0, to find the limit we can use what's called L'Hôpital's rule. Let's take, for example, the limit of f of x over g of x as x approaches c. If the limit as x approaches c of f of x is equal to 0, and the limit as x approaches c of g of x is also equal to 0, and the limit as x approaches c of f prime of x over g prime of x exists and is equal to k, then we can say that the limit as x approaches c of f of x over g of x is also going to be equal to k. This might be a little confusing at first, but don't worry, we'll do an example. For example, let's say we wanted to find the limit of x approaches 0 of sine x over x. We'd get an indeterminate form of 0 over 0. We can use the L'Hôpital rule to see if this limit exists. We start by finding the derivative of sine x and the derivative of x. The derivative of sine x is cosine x, and the derivative of x is 1. Per the L'Hôpital rule, let's try to find the limit of cosine x over 1 as x approaches 0. That's going to be equal to 1 over 1. This means that according to the L'Hôpital rule, the limit of sine x over x as x approaches 0 is equal to the limit of cosine x over 1 as x approaches 0, which is 1.
Alright, that was pretty cool. Let's look at another example. Alright, let's say that we need to find the limit of this expression here. We see that it's in quotient form, so we know that we have the option of using L'Hôpital's rule as long as it is in indeterminate form. By using direct substitution, we can see that this quotient, it is indeed in indeterminate form. So let's go ahead and use L'Hôpital's rule. Okay, so now we find the derivatives of f of x over g of x separately. We come to the conclusion that the derivative of x squared minus 9 is 2x by the power rule, and the derivative of x minus 3 is 1. Alright, so now we're going to take the derivatives that we just found, we're going to plug them into the original equation, and we're going to use direct substitution again. As we can see, by plugging in 3 into all of our x's, we get 6. That is our final answer. Alright, that was rather simple. I actually think that pronouncing L'Hôpital is probably the hardest part of the rule. It is also important to note that if you get to this point, and instead of getting a real number answer, like 6, you get an indeterminate answer, you'd have to find a second derivative. You'll do this until you find a real number answer. Sometimes you might have to find a third derivative, or a fourth, hopefully not. I think we can all agree that L'Hôpital's rule is pretty cool. Maybe not as cool as learning how to ride a dragon or how to survive a zombie apocalypse, but it is a handy tool nonetheless, especially for solving limits of indeterminate forms. Thank you for tuning in. If you have any questions, please contact us. If you liked this video, please subscribe to our channel so you'll never get new video updates. Goodbye!